Um, okay, here we have an indefinite integral, and it's the indefinite integral of the natural log of the square root of t over t dt. And you could really hurt yourself with this integral, even though it's fairly easy. But you could really hurt yourself with it if you tried to just do some u substitution straight away. If you tried to do some u substitution and if you let u equal t, that's not going to do anything for you. If you let u equal the natural log of or if you let u equal the square root of t, that's not really going to do much for you either, because you'd still end up with some leftovers, and I don't know that you'd really be able to do anything with it at that point. You could let u equal the natural log of the square root of t, and you might get a little closer to it, but I don't think you would get quite what you wanted. I'm trying to do a little bit in my head, and yeah, I don't think you'd get quite what you want. Well, actually you would. It just would be a little harder to do. Actually, that wouldn't be a bad idea. But I'm not going to tell you to do that, because I think there's a smarter way to do that. You could say u equals the natural log of the square root of t, and when you took the derivative, you would get 1 over the square root of t times the derivative of the square root of t, which is 1 over 2 square roots of t. Right? Yeah. Or 2 over the square root of t. Sorry. And then you square root of t times square root of t, and you would have it. But actually, there's an easier way to do that. Arrive at the same thing, is to recognize that this is the natural log of t to the 1/2 power. And then to know that if you have an exponent on the argument of a logarithm, you can bring that exponent down in front of that logarithm as a product. And now you have 1/2 times the natural log of t over t dt, and I can factor out that 1/2 to say that that's 1/2 over the natural log of t, times the natural log of t over t dt. Now the u substitution is much more direct than it would have been before. So I can say let u equal the natural log of t, du equals, you should know that the derivative of the natural log of t is 1 over t, and you have that in your integral, so that's why you would choose that. Du equals 1 over t dt. I have that exactly in my integral here, so I'll just substitute that in and say that that's 1/2 times u, and then dt over t is equal to du, and then, man, it just really can't get any easier than that. Up by a power of 1 over the new power plus c, make that a 1/4. U is now, it was ln of t, and then that's squared. So, and you can't do anything with this squared because it's the whole logarithm squared. So it's 1/4 times the natural log of t squared plus c. Not the natural log of t squared, but the natural log of t squared.